Now we discuss corrosion of metals. Do you know corrosion? The slow process of decay or destruction of metal due to the effect of air, moisture, and acid on it is known as corrosion. The slow process of decay, destruction of metal due to the effect of air, moisture, and acid on it is known as corrosion. Have you seen the following things such as old iron bars of buildings, copper vessels not cleaned for a long time, silver ornaments or idols exposed to air for a long time, old abundant vehicles fit to thrown away? Why do you why do pure gold and platinum always glitter? Now, tell me please, why do pure gold and platinum always glitter? Because uh, gold as well as platinum are noble metals. They do not react with moisture, oxygen, carbon dioxide, acids, and alkali. So they are always glitter. Pure gold as well as platinum, they are noble metals, so they do not react with moisture, oxygen, carbon dioxide, acids, alkalis, so they are always glitter. Rusting of iron articles causes large financial loss, thus corrosion of iron, that is rusting is a big problem. Iron reacts with moisture and a deposit of a reddish substance. Chemical formula Fe2O3 is formed on it. This substance is known as rust. Now, carbon dioxide is present in moisture, reacts with the surface of copper vessel. Copper loses its luster due to formation of a greenish layer of copper carbonate. That greenish layer is a poisonous layer. This is called as patination of copper. Exposure to air, silver articles turns blackish after some time. This is because of a layer of silver sulfide is formed by the reaction of silver with hydrogen sulfide that present in air. By oxidation of aluminium, a thin layer of aluminium oxide forms on it. Prevention of corrosion. Various methods are used to protect metals from corrosion. Special attention is paid in almost all the methods so that iron does not rust. We can lower the rate of the process of rusting of iron. Corrosion of metals can be stopped by keeping metals isolated from direct contact with air. The prevention of corrosion can be achieved by various ways. Some of these methods are as follows. Now, first method is to fix a layer of some substance on the metal surface so that the contact of metal with moisture and oxygen in the air is prevented and no reaction would occur between them. To prevent corrosion of metals by applying a layer of paint, oil, grease or varnish on their surface. For example, corrosion of iron can be prevented by this method. Can you permanently prevent the rusting of iron article by applying a layer of paint or a layer of paint on its surface? We can lower the rate of the process of rusting of iron. We are not able to permanently prevent the rusting of an iron, but we can lower the rate of the process of rusting of iron. We cannot protect the articles permanently from rusting by painting them. The method of painting is suitable for short time. If there is a scratch on the paint on the surface of the article, and if a small surface of a metal comes in contact with air, the process of rusting starts below the layer of the point. Now, we prevent corrosion by some methods. First method is galvanizing. In this method, a thin layer of zinc is applied to prevent corrosion of iron or steel. For example, shining iron nails, pins. In this method, corrosion of zinc occurs first because zinc is more electropositive than iron. After a few rainy season, the zinc layer goes away and the inner iron gets exposed, then iron starts rusting. Now, second method is a tinning. In this method, a layer of molten tin is deposited on metal. We call this as coloring. A greenish layer forms on the surface of copper or brass. This greenish layer is poisonous. If buttermilk or curry is placed in such a vessel, it gets spoiled. Tinning is done to prevent all such damages. Now, third process is anodization. In this method, metals like copper, aluminium are coated with a thin and strong layer of their oxides by means of electrolysis. For this, the copper or aluminum article is used as anode. As this oxide layer is strong and uniform all over the surface, it is useful for prevention of corrosion of the metal. For example, when aluminum is anodized, the thin layer of aluminum oxide is formed. It obstructs the contact of the aluminum with oxygen and air, as well as the atmosphere. This prevents further oxidation. This protection can be further increased by making oxide layer thicker during the anodization. Now, fourth preventive method of metal electro plating. In this method, a less reactive metal is coated on a more reactive metal by electrolysis process. For example, silver plated spoon, gold plated ornament are the examples of electroplating. Alloying. Majority of the metallic substances are presently used in the form of alloy. The main intention behind this is to decrease the intensity of corrosion of metals. The homogeneous mixture formed by mixing a metal with other metals or non-metals in a certain proportion is called an alloy. For example, bronze is an alloy formed from 90% copper and 10% tin. Bronze statues do not get affected by sun and air. We also know that stainless steel does not get stained with air or water and also does not rust. It is an alloy made from 74% iron, 80% chromium, and 8% carbon. In recent time, various types of alloy are used for minting coins. Now we start a third chapter. Name of that third chapter is chemical reactions and equations. Do you know chemical reaction is a process in which some substances undergo bond breaking and are transformed into new substances by formation new bond. Substance taking part in chemical reaction are called as reactants, whereas the substance formed as a result of a chemical reaction by formation of new bonds are called products. For example, formation of a carbon dioxide gas by combustion of coal in air is a chemical reaction. In this reaction, coal, that is carbon as well as oxygen, are reactants, while carbon dioxide is formed in that chemical reaction, that is a product. We can easily represent that reaction in the form of word form as well as in the form of chemical equation. Chemical equation. Now we already know that chemical equations chemical equation we represent in the form of formulae as well as in the word form. Now first time we discuss writing of chemical equations. Now we take a first example. Colorless solution of zinc sulfate is formed. Addition of zinc dust to the blue colored solution of copper sulfate. Aqueous solution of copper sulfate plus zinc dust to form colorless aqueous solution of zinc sulfate and copper. This simple way of representing a chemical reaction in word is called as word equation. This is a word equation of a chemical reaction. Now we condense that word equation by use of chemical formulae as follows. Now the chemical formula of copper sulfate is CuSO4. Chemical formula of zinc is Zn. CuS copper sulfate plus zinc. Then when chemical reaction is completed to form a zinc sulfate and copper. Now the representation of a chemical reaction in a condensed form using chemical formulae is called as a chemical equation. In the above equation, copper sulfate and zinc both are reactants, and zinc sulfate as well as copper, they are a product. Properties of products and reactants are totally differentiated from each other. The ionic bond in the reaction copper sulfate breaks, and the ionic bond in the product zinc sulfate is formed during the reaction. Writing of chemical equations. Let us now see the convention followed while writing a chemical equation. First time, a first convention or a first rule is in a chemical equation, the reactants are written on left hand side while the products on right hand side. An arrow heading towards the products is drawn in between them. This arrow is always indicates the direction of the reaction. If the reactants or products are two or more, they are linked with a plus sign in between them. For example, in equation number 2, a plus sign is drawn in between reactants copper sulfate and zinc. Similarly, plus sign is also drawn in between product zinc and copper. To make the chemical reaction more informative, the physical state of reactants are indicated in the equation. Their gaseous, liquid, and solid states are indicated by writing the letters G, L, S respectively in the bracket. Moreover, if the product is gaseous instead of a G, it can be indicated by an arrow pointing upwards. If the product formed is insoluble or solid, that is in the form of precipitate, then instead of yes, it can be indicated by arrow pointing downwards. When reactants and products are in the form of solution in water, they are said to be present in aqueous solution state. This state is indicated by putting a letter AQ in a bracket after their formula. Now, thus equation number 2 can be written as copper sulfate aqueous plus zinc solid. Arrow, the mouth of arrow is directed towards the product zinc sulfate aqueous plus copper. When heat is to be given from outside to bring about a reaction, it is indicated by the sign, such a sign written above the arrow that indicates the direction of the reaction. For example, reaction in which slaked lime is formed on heating limestone is written as follows. Calcium carbonate that is lime. When we heat limestone to form a slaked lime as well as carbon dioxide. That is, when we heated limestone, carbon dioxide gas will be released. Similarly, the fact that heat is released during the reaction between the aqueous solution of copper sulfate and zinc dust is indicated as copper sulfate plus zinc dust, zinc sulfate, aqueous plus copper and heat. Now, when we add zinc dust in the aqueous solution of copper sulfate to form zinc sulfate plus copper as well as heat will be formed in this reaction. We represent formation of heat in the production with plus sign. It is necessary to fulfill certain conditions like specific temperature, pressure, catalyst to bring about some reactions. These reactions are indicated below or above the arrow indicating the direction of the reactions. For example, the reaction of vegetable oil takes place at a specific temperature such as 60 degrees Celsius with hydrogen gas in presence of nickel catalyst, and that reaction will be written as vegetable oil plus hydrogen gas. We represent a temperature, specific temperature 60 degrees Celsius above the arrow, and we also represent nickel catalyst below the arrow. That arrow directed, mouth of that arrow is directed towards the product, and the product is formed vanaspati ghee. Now, specific informations or names of reactants as well as products are written below the formulae. For example, copper on a reaction with concentrated nitric acid gives a reddish colored poisonous nitrogen dioxide gas. When copper reacts with concentrated nitric acid to form a copper nitrate, nitrogen dioxide gas plus water. Now, when copper reacts with dilute nitric acid to form copper nitrate, and nitrogen oxide as well as water. Now, we study another reaction. A word equation is written for the activity such as silver nitrate. A solution of sodium chloride is added in a aqueous silver nitrate solution to form white colored silver chloride precipitate as well as aqueous sodium nitrate. Now, balancing a chemical reaction. That chemical reaction is such as silver addition of aqueous sodium chloride in a aqueous silver nitrate solution to form silver chloride white precipitate as well as sodium nitrate. When we balance the atoms of elements in both reactants and products in the reaction, atoms present in reactants, that is compounds present in reactants and compounds present in product. When we observe atoms of elements present in compounds, number of atoms present in reactants and number of atoms present in products, if there are same in number, all atoms in products and all atoms in reactants, then that reaction is known as a balanced reaction. If any reaction, the total mass of each of the element in the reactants is same as the total mass of each of the respective elements in the product. This is in accordance with the law of conservation of mass that you studied in the previous standard. Now, step in balancing a chemical reaction. Now, take a chemical reaction such as sodium hydroxide reacts with sulfuric acid to form a sodium sulfate and water. Step first, such as we write that chemical reaction in the form of formulae. Now we see that chemical reaction is sodium hydroxide NaOH plus sulfuric acid to form a sodium sulfate plus water. Now first time we count atoms of elements both in reactants and products. Now we create a table such as elements, reactants, they are represent in left hand side, products they are represent on right hand side, and elements are such as in that the chemical reaction is sodium, oxygen, hydrogen and sulfur. Now in reactant, sodium atom is 1, oxygen atom is 5, hydrogen atom is 3 and sulfur atom is 1. Now in product, sodium atom is 2, oxygen atom is 5 and hydrogen atom is 2 and the sulfur atom is 1. Now step second, it is convenient to start balancing an chemical equation from the compound which contains the maximum number of atoms. Moreover, it is convenient to first consider that element in this compound which has unequal number of atoms on the two sides. In this equation, there is two components such as Na2SO4 and H2SO4 which contains the maximum numbers, that is 7 atoms each. Now any one of them can be selected. Select the compound Na2SO4, further select sodium for balancing as the number of atoms of sodium in this compound is unequal on two sides. It should be remembered that the formula of a compound cannot be changed while balancing the number of atoms. It means that here to make the number of sodium atoms in the reactant as 2, the formula NaOH cannot be changed to Na2OH instead of a factor of 2, while have to be applied to NaOH. Now we firstly balance sodium atom in products and in reactants. In reactants, initially 1 sodium atom is present, and in product, initially 2 sodium atom is present. Now, in such condition, we balance the sodium atoms in reactants. When we take a coefficient 2, then the atoms of sodium are similar in reactants as well as in products. Then we represent a reaction again such as 2NaOH plus H2SO4 arrow Na2SO4 plus H2O. Check the reaction balance or not. Now check all number of atoms present in reactants as well as products. Elements are such as sodium, oxygen, hydrogen and sulfur. Reactants, number of atoms present in reactants: sodium 2 atoms, oxygen 6 atoms, hydrogen 4 atoms, sulfur 1 atom. Now number of atoms in product: sodium 2 atoms, oxygen 5 atoms and hydrogen 2 atoms as well as sulfur 1 atom. Step 5th, such as, now in second step, check whether the equation number 10 is balanced or not. It is seen that the number of atoms of all elements are equal on both the sides. It means that the equation 10 is a balanced equation. But we see the equation 10 is balanced equation. We find that the equation 10 is not balanced. Equation 10 is not balanced when number of atoms are present in right hand side as well as number of atoms are present in left hand side. Both are equal, then the equation is known as a balanced equation. But in this case, apply a factor 2 the product H2O for balancing the equation. Huh? Now in second time we balance hydrogen atom. We balance hydrogen atom in a product. Now we see the hydrogen atom present in reactants 4 hydrogen atom and hydrogen atom present in products is 2 hydrogen atom. When we take a coefficient 2 in a product, then both hydrogen atoms are present in reactants and products are same, and we take a coefficient in front of water in the product, then we represent a chemical reaction such as 2NaOH plus H2SO4 arrow Na2SO4 plus water. Now check the atoms present in reactants as well as products. Both atoms in reactants as well as products are same. So the equation is a final balanced equation that represents such as 2NaOH plus H2SO4 arrow Na2SO4 plus 2H2O. Now, the final balanced chemical equation are such as sodium hydroxide plus sulfuric acid to form sodium sulfate and water. In this way, a balanced equation is obtained from an unbalanced equation by applying proper factors to appropriate reactants as well as products so as the balanced number of each element in every step. Types of chemical reaction. Now we are studying types of chemical reactions. There are chemical reactions are classified into the following 4 types in accordance with the nature and number of the reactants and the product. First type of chemical reaction is combination reaction. Now we complete a single activity. Take a small amount of hydrochloric acid in a test tube. Heat the test tube. Dip a glass rod in the ammonia solution and hold on the top of the test tube. You will observe a white smoke emitting from the tip of the glass. What must have happened? Due to heating, HCl vapors started coming out from the test tube and ammonia gas came out from the solution on the glass rod. The ammonia gas and hydrogen chloride gas reacted to form a salt ammonium chloride in a gaseous state first, but immediately due to the condensation process at room temperature, it got transformed into solid state. As a result, white smoke was formed. The chemical equation for this such as ammonia gas plus hydrogen chloride gas to form ammonium chloride. It is in a solid state. Activity number 2 is such as hold a magnesium strip in a pair of tongs and ignite. On burning in air, a white powder of magnesium oxide is formed. The reaction can be written in the form of equation as shown. Magnesium plus oxygen to form a magnesium oxide as a single product by combination of magnesium and oxygen. Now activity number 3, take water in a beaker up to half of its capacity, add a few pieces of slaked lime to it. Calcium hydroxide is formed by combination of a calcium oxide and water with generation of large amount of heat. We represent the chemical equation is such as calcium oxide plus water to form products such as calcium hydroxide, and heat also released in large amount. Now, when we observed the both three reactions, only one product is formed. So we write or we represent the definition of combination reaction is such as when two or more reactants combine in a reaction to form a single product, it is called as combination reaction. Now, second reaction is a decomposition reaction. Take some sugar in evaporating dish and heat it with the help of a Bunsen burner. After some time, you will see the formation of a burnt out black substance. Exactly what must have happened in this activity. In the above activity, a single reactant, name of that reactant is sugar, is divided into two substances. Formula of sugar is C12H22O11. When sugar is heated to form carbon as well as water, the reaction in which there is only one reactant giving rise to or more products is called a decomposition reaction. Now we complete the second activity, such as apparatus are used in second activities. There are two test tubes, bent tube, a rubber cork, burner, chemicals, calcium carbonate, freshly prepared lime water. Procedure: take some calcium carbonate in a test tube. Fit a bent tube to this test tube with the help of a rubber cork. Insert the other end of the bent test tube in a freshly prepared lime water taken in the other test tube. Heat the powdered calcium carbonate in the first test tube strongly. The lime water turns milky. We saw in the above activity the calcium carbonate undergoes decomposition reaction and carbon dioxide gas is formed, turns a lime water milky. The second product of reaction is calcium oxide powder remains behind in the first test tube. Now, similarly, we complete a second reaction such as hydrogen peroxide naturally undergoes slowly decomposition into water and oxygen. Chemical formula of hydrogen peroxide is H2O2. When it decomposes naturally to form water as well as oxygen gas released. We have studied in the previous standard such as the decomposition of water. When we heat water simply, liquid water converts into vapor. But when we pass electricity through the acidulated water, the decomposition of water will be takes place by means of electrical energy, and we get two substances or two products such as hydrogen and water. We represent that reaction is such as H2O. There is a, we represent electricity, passing electricity or by use of electricity, we decompose water into hydrogen and oxygen. The chemical reaction in which two or more products are formed from a single reactant is called a decomposition reaction. Many degradation processes take place in the nature surrounding us. Organic waste is decomposed by microorganisms, and as a result, manure and biogas are formed. Biogas is used as a fuel, and manure is used in the field to increase the fertility of soil. Now, third type of reaction is displacement reaction. Now we already know that when a zinc dust is added in a blue colored solution of copper sulfate, zinc displaces copper from its compound and form a zinc sulfate, as well as heat will be released. From that we learned Zhadian dipositive ions formed, Zhadian atoms, takes the place of copper dipositive ions in copper sulfate, and copper atoms formed from copper dipositive ion come out. It means that Zhadian displaces copper from copper sulfate. Zhadian is more reactive than copper. So Zhadian easily displaces copper from its compound and take the place of copper. The reaction in which the place of the ion of a less reactive element in a compound is taken by another more reactive element by formation of its own ion is called displacement reaction. Now complete the following two reactions: aqueous copper sulfate plus iron to form iron sulfate and copper. Reaction of copper sulfate plus solid lead to form a lead sulfate and copper. Now fourth type of reaction is double displacement reaction. Now we already seen the reaction is such as when aqueous sodium chloride is added in aqueous solution of silver nitrate to form white precipitate of silver chloride as well as sodium nitrate. The reaction in which the ions in the reactants are exchanged to form a precipitate are called double displacement reactions. Now we represent a new chemical reaction is such as addition of potassium chromate into the solution of barium sulfate. When we add potassium chromate into the solution of barium sulfate to form barium chromate and potassium sulfate, to form barium chromate and potassium sulfate. Now tell me some answers of questions. What was the color of a precipitate is formed when we add potassium chromate in the solution of barium sulfate? Then we get products are such as barium chromate as well as potassium sulfate. What was the color of precipitate is? The color of precipitate is yellow. Right, the name of precipitate is barium chromate, and we can easily write the balanced equation for this reaction. We write the balanced equation such as barium sulfate plus potassium chromate to get the product barium chromate as well as potassium sulfate. Will you call this reaction a displacement reaction or a double displacement reaction? That reaction is known as a double displacement reaction. Now we study another types of reactions such as exothermic reactions as well as endothermic reaction. Heat is absorbed and given away in various processes and reactions. Accordingly, processes and reactions are classified as endothermic reaction and exothermic reaction. Heat from outside is absorbed by some physical change. For example, melting of ice, dissolution of potassium nitrate. In both reactions, heat is absorbed from surrounding. Therefore, such reactions are known as endothermic reaction. On the other hand, heat is given away during some physical changes. For example, formation of ice from water, dissolution of sodium hydroxide in water. In both reactions, heat is released, so such reactions are known as exothermic reactions. In the process of dilution of concentrated sulfuric acid with water, a very large amount of heat is liberated. As a result, water gets evaporated instantaneously. If it is poured into the concentrated sulfuric acid, which may cause an accident. To avoid this, required amount of water is taken in a glass container and a small quantity of concentrated sulfuric acid at a time is added with the stirring. Therefore, only a small amount of heat is liberated at a time. In such way, we convert concentrated sulfuric acid into dilute sulfuric acid. Now, another more examples of endothermic reactions as well as exothermic reaction. When we heat calcium carbonate to form calcium oxide as well as carbon dioxide gas will be released. In this chemical reaction, we provide heat. When we provide heat, then the reaction is completed. So that reaction is known as endothermic reaction. Calcium oxide, when add in water to form calcium hydroxide, as well as heat is released from this reaction. So that reaction is known as exothermic reaction. Rate of chemical reactions. Rate of chemical reactions are not similar. That is, rate of chemical reactions are differentiated. It means that the rate of different reactions is different. The same reaction occurs at a different rate on changing conditions. For example, during winter, long time is required for setting milk into curd, while at a higher temperature during summer, the rate of setting of milk increases and the curd is formed. Now let us see the factors which decide the rate of a chemical reaction. Now first factor is nature of the reactants. Let us see the reaction of metals, aluminum and zinc with the dilute hydrochloric acid. Both aluminum and zinc reacts with dilute hydrochloric acid and the hydrogen gas will be released. However, reaction of aluminum metal takes place faster as compared to zinc metal. The nature of the metal is responsible for this difference. Aluminum is more reactive than zinc. Therefore, the rate of reaction of aluminum with hydrochloric acid is higher than that of zinc. Nature of reactivity of reactants influences the rate of chemical reactions. We already know that the reactivity of metals. Now, second factor is size of the particles of reactants. The complete activity is such as take two test tubes, balance measuring cylinder, chemicals such as pieces of Shabat tile, powder of Shabat tile, dilute hydrochloric acid. Take some pieces in a first test tube of Shabat tiles. Now take a powder of Shabat tile in second test tube. Both chemicals have an equal weight and add 10 ml dilute hydrochloric acid in each test tube. Observe whether effervescence of carbon dioxide is formed at a faster or slower speed. You must have found in the above activity that the carbon dioxide effervescence is formed in both reactions, but if carbon dioxide effervescences are formed in such reaction, we use the powder of Shahaba. Now, in second reaction, we also use the pieces of Shahabat and also formed carbon dioxide. But the speed of chemical reaction is faster. In such reaction, we use powdered Shahabat. The above observation indicates that the rate of chemical reaction is depend upon the size of the particles of the reactants taking part in the reaction. Smaller the size of the reactants particles, higher is the rate of reaction. Now, another factor that also affect the rate of chemical reaction, concentration of reactants. Now we take both types of both types of acids such as the dilute hydrochloric acid and concentrated hydrochloric acid. Take two test tubes, and in both test tube we take a powder of calcium carbonate. Now in first test tube slowly add in this powder dilute hydrochloric acid, and we add in second test tube concentrated hydrochloric acid. Dilute hydrochloric acid reacts slowly with calcium carbonate, and thereby calcium carbonate disappears slowly, and carbon dioxide also liberates slowly. On the other hand, the reaction with concentrated hydrochloric acid takes place rapidly and calcium carbonate disappears fast. Concentrated acid reacts faster than dilute acid, which means that rate of reaction is proportional to the concentration of reactants. Now, second factor that affects the rate of reaction, temperature of a reaction. We already studied the decomposition of calcium carbonate. When we provide heat, that time calcium carbonate will be decomposed. While studying the decomposition reaction, you have carried out decomposition of limestone. In this activity, the lime water does not turn milky before heating the limestone because of a zero rate of reaction. From this, it is learned that the rate of a reaction increases on increasing the temperature. Catalyst is also affect the rate of reaction. On heating, potassium chlorate decomposed slowly. When we heat potassium chlorate to form potassium chloride and oxygen, the rate of our reaction neither increased by reducing the particle size nor by increasing the reaction temperature. However, potassium chloride decomposes rapidly in presence of manganese dioxide to liberate oxygen gas. No chemical change takes place in manganese dioxide in this reaction. The substance in whose presence the rate of a chemical reaction changes without causing any chemical change to it is called as catalyst. The decomposition of hydrogen peroxide into water and oxygen takes place slowly at room temperature. However, the same reaction occurs at a faster rate on adding manganese dioxide powder as a catalyst. Now, we stop here